myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we learn about the concept in C that is called as dynamic memory allocation. So what is dynamic memory allocation? What are the different functions involved in dynamic memory allocation? And then also we'll see some of the programs. So here memory allocation is nothing but allocating physical or virtual memory space to computer programs and services. So when we write programs, so for that memory is allocated. So it can be allocated in two ways. First one is static memory allocation and next one is dynamic memory allocation. So here memory allocation is divided into two types based on how it is occurring, based on how the memory is allocated. So whether it is allocated before or during program execution. So first one is static memory allocation, next one is dynamic memory allocation. So here in detail we'll discuss about this second one, that is dynamic memory allocation. So here when we create variables, so static memory allocation is nothing but memory which is allocated during compile time. Memory allocated during compile time. During compile time is called as static memory allocation. So memory allocated during compile time is called as static memory allocation. So once when we write the programs, memory for the program, when we write the program at compile time itself, the memory is allocated. So that is called as static memory allocation. So in static memory allocation, so once we declare some specific size, so that the memory allocated which is allocated, that will remain fixed. So during execution of the program, we cannot change the memory which is allocated. So memory layout of C program. So next one is, so example for let us see what is, let us understand what is static memory allocation. Suppose in the program we have, so this is a program, and if we declare a variable int a, so here memory for this variable a is allocated, that is 4 bytes of memory for this variable a is allocated. Now suppose if we declare an array whose size is 5, and here memory allocated for this array will be, memory is allocated for 5 elements of the array. So size of the array is given by, size of the array is 5. So memory which is allocated is given by 5 into 4. This 4 depends upon the size of integer. Size of integer varies from computer to computer. So it may be 4 bytes or 2 bytes. So generally it is 4 bytes. So 5 4s are 20. So 20 bytes of memory will be allocated. Now if we want to use if we are storing all the values here, if we are initializing the array with all the values, suppose 1, 2, 3, 4 and 5. Then all the 5 values will be stored in the memory, will be stored in the array here, 1, 2, 3, 4, 5. Now suppose if we want to store only, so here return 0 is also there. So if we want to store, instead of this statement, if we want to store less number of elements, so we have to declare the size as 5 only, and if we store only 3 elements, so remaining 2 elements memory is wasted. So remaining 8 bytes of memory is wasted. So in order to avoid this, so we go for dynamic memory allocation. So dynamic memory allocation is nothing but during execution time, during execution time, memory is allocated for the variables. So let us see the memory layout of C program. So dynamic memory allocation takes place in the heap area. This is the heap is nothing but this is the memory segment. This is the memory segment where dynamic memory allocation takes place. So whenever we use dynamic memory allocation, the concept of dynamic memory allocation, the memory segment associated with this is the heap segment. So these are the other segments. We have stack segment. So unlike the stack segment, so in the heap segment, in the heap memory segment, the values are, memory is allocated or deallocated randomly. So it does not allocate or deallocate with any order. So it is done randomly. So there are some functions associated with dynamic memory allocation. So in order to allocate memory dynamically, so there are some functions. So these functions are declared in the library file, in the header file stdlib.h. So as we need to, so the functions associated with dynamic memory allocation, these are declared in the header file stdlib.h. So before going into detail, let us see some more concepts of static memory allocation. So we have seen that memory allocated for the program during compile time. So during compile time, if memory is allocated, that is called as static memory allocation. The disadvantage with this is once the size is fixed, we cannot increase or reduce the size. The compiler allocates the required memory for the program before the execution of the program. So since memory allocation takes place during compile time, it is also called as compile time memory allocation. Next, coming to dynamic memory allocation. When memory for the program is allocated during execution time, so when we are executing the program, at that time if memory is allocated, that is called as dynamic memory allocation. The compiler allocates the required memory for the program during the execution of the program. So it is also called as runtime memory allocation because during runtime or execution time, program memory is allocated. This allows the programs to allocate memory for variables or data structures whose size is determined during runtime or can change during the program's execution. So this avoids, because of dynamic memory allocation, so memory wastage is avoided. So there are several functions for dynamic memory allocation. So these are declared in stdlib.h header file. So in order to use these functions, so these are the different functions used for dynamic memory allocation. So in order to use these functions, we have to include the header file stdlib.h in our program. So these are the functions which are responsible for dynamic memory allocation. First one is malloc, then we have calloc, then realloc, and then free. So here the most widely used is malloc and free. So malloc, let us see one by one in detail. So first one is malloc. So this is declared in the header file stdlib.h. So in order to use this function, so this is a built-in function. Malloc is a built-in function which is declared in the header file stdlib.h. So malloc stands for malloc, or you can say malloc. So memory allocation. M, then alloc, memory allocation. It is the malloc is nothing but short form of, so it is the short form for memory allocation. It is used to dynamically allocate a single large block of memory with a specified size. So it will allocate single large block of memory. Suppose the user is requesting to allocate 20 bytes. So it will allocate 20 bytes of memory in the heap segment. So this memory is allocated in the heap segment, and then it will return a void pointer. So starting address, suppose it is 1000. So it will return a void pointer. So this PTR, the type of this is void pointer. Why? Because malloc doesn't know what are the elements or what type of data will be stored here. So therefore it will return a void pointer. And then in order to store a particular values, in order to store a particular type of data in this memory, the user has to typecast it. So typecasting can be done. So this is the syntax for using malloc function. So this is the syntax. So this malloc is the function, name of the function is malloc, and inside this we write the byte size. So how many bytes are to be allocated? Suppose for example 20 bytes are to be allocated. So here byte size will be 20 now. So then after that, after allocating memory in the heap segment, it will return a void pointer. That means it will return a pointer which is pointing to the base address, which is pointing to the starting address of the memory which is allocated. So here void pointer, it returns a void pointer because it doesn't know what type of element or what type of data will be stored in this memory. So therefore we need to typecast it. So in order to typecast it, so this is the syntax. So inside the braces we need to write the specific. So suppose we need to store here integer values, then we can typecast it to an integer pointer. Then this will give the address. This address is stored in the pointer variable PTR. So whatever after typecasting, the memory which is allocated, so that base address is stored in the variable ptr. Then for example, consider this example. So here we have declared an array, we have declared a pointer variable. The name of the pointer variable is ARR. Name of the pointer variable is ARR. So address, this will store an address. So in order to use the pointer, we need to assign some address here. So it is assigned the address which is returned by this malloc function. So this malloc function, this statement implies that we are allocating memory which is equal to 5 into size of int. So this size of int varies from computer to computer. So therefore we have written size of int here. So suppose it is 4. So 5 into 4 is equal to 5 4s are 20. So 20 bytes of memory will be allocated, and the base address of this. Suppose we need to store here, if we are storing integer values in this memory, then we have to typecast it to integer pointer, and that address will be stored in the pointer variable ARR. So in this way, so let us see one example for malloc function, how to use the malloc function. So this is a program, so where we have used malloc function in order to allocate memory for some number of integers. For 5 integers we have allocated memory during runtime. So this is a program. We have declared two integer variables n and I. So n is nothing but the number of elements, which gives how many elements do we need the memory. So scanf, so in the scanf function, %d is the format specifier and ampersand n. So at this address, the value will be stored. Then after that, we need to, in order to dynamically allocate memory for an integer array of size n. So for an integer array of size n, the array size is n. So in order to store n values or n number of integers, so this is how we can use the malloc function. So suppose we need to store 5 integer values. So 5 into, inside this malloc function, so here n is equal to 5. Suppose n is equal to 5. So 5 into size of int, so that is 4, is equal to 20. So after that, so this will come under malloc. So this 5 is nothing but n into size of int. And then this will return a void pointer. So in order to store integer values, so we need to typecast it. So typecasting is done as in this way. And the address which is returned, the base address of this, which is returned by this malloc function, that is stored in the variable ARR, integer pointer. So in order to store the address, we need a pointer. So that pointer variable is ARR. So if the memory is allocated successfully, if the memory is not allocated successfully, then we have to check this condition. If ARR is equal to null, so that means if the value in this is equal to 0, if it is not pointing to a valid, if the memory is not allocated to this, or ARR is equal to null, then memory allocation failed. Then we have to exit from the program. If memory is allocated successfully, then these are the different statements which are executed. So in scanf function, so by means of scanf function, the user is giving the input values, or the user is giving the input integers. So at this particular address ARR, name of the pointer is ARR. So ARR plus I. So ARR plus I means I is equal to 0, starting from 0. So this array size, suppose we want 5 integers, memory is allocated for 5 integers. So this loop will repeat 5 times from 0 to 4. So at this particular address, in the scanf function, we need to give the address where the value will be stored. So this is the address at which the value has to be stored. I is ARR plus 0 means the first element. Suppose this is the address 1000. So first element is stored at this particular location. Then ARR plus 1 means 1000 plus. So we have seen this in pointer arithmetic. Plus 1 means 1 into 4. So this 1 is nothing but this 1 into the size of integer. Since this is a pointer to an integer, so therefore size of integer is 4. So this will be 1004. So at this particular address, the next value will be stored, which is given by the user. Suppose the user is entering 10, 20, 30, 40 and 50. So then in order to display the values which the user has given, so this is these are the statements. So by using for loop, we are printing all the elements of the array on the screen. So in order to print the values with the help of the pointer, we need to dereference the array. We need to dereference. So ARR, so at this particular address, what is the value? So that value is printed on the screen. ARR plus I means this address 0. So at this particular address, what is the value that can be obtained by using dereference operator? So value at this address is given by 10. So these are whatever the values the user has given, so those will be displayed on the screen. So 10, 20, 30. If these are the input, then this will be the output which is given on the screen. So array elements. This is the output of this program. In this way, memory is allocated by means of using malloc function. Next one is, and one more thing. So using malloc, when memory is allocated using malloc function, so it will store garbage values. So if we don't initialize it, it will store garbage values. The next one is calloc function. Calloc is contiguous allocation. Calloc stands for calloc or contiguous allocation, or in some textbooks it is also written as clear allocation. So this function is used to dynamically allocate the specified number of blocks of the memory of specified type. So as compared to malloc, this calloc function, so function of calloc is also same. It will allocate the specified number of blocks, number of memory for the specified memory for the data to be stored. Specified memory, then calloc function, what it does is it requires 2 arguments, whereas malloc function requires only 1 argument. Calloc function requires 2 arguments. Other difference between calloc and malloc is calloc function initializes each block with a default value 0, whereas malloc, in case of malloc, the block of memory is initialized with garbage value. So here each block is initialized with a default value 0. So it has 2 parameters or arguments as compared to malloc. So that is the difference between, so you can see here, this is the difference between calloc and malloc. So calloc, it initializes each block with a default value 0. It has 2 parameters or arguments as compared to malloc. So malloc, what it does is it allocates single block of memory of the specified type. Suppose 20 bytes are required. So 20 bytes are allocated in a single block. So whereas in case of calloc, so we need to give the 2 parameters. So we need to mention the blocks, number of blocks as well as the block size. So block size of, so this will be done in this way. Suppose 20 bytes are required, and so here we have specified 5 here. So number of blocks are 5, 1, 2, 3, 4 and 5, 1, 2, 3, 4, 5. So 5 blocks will be allocated in 5 blocks. So element size, suppose size of each block is 4 here. So total 20 bytes will be allocated. So in this way, calloc also allocates 20 bytes, but here this function is used to dynamically allocate the specified number of blocks. So user has to specify the number of blocks in addition to the also the block size also the user has to mention. So syntax for this is, so calloc also returns a void pointer. So in order to store the address, it also returns a void pointer similar to malloc here. So we need to typecast it into a particular type. So so that the pointer can point to if we want to store integer values, then we have to typecast it to integer. Then if we want to store float values, then we have to typecast it to a float pointer. So syntax for this is this. So this is the address. So this is the pointer variable, PTR, name of the pointer variable. So at this particular it has the base address of the memory which is allocated by using this calloc function. So here in this, n is the number of elements, or you can say number of blocks which are allocated, number of blocks, and element size is the size of each element, or you can say this is the size of each block. So example for this is, suppose we declare a pointer variable of type double. That means this is a pointer which is pointing to double data type. So here this will store the pointer has to be assigned. So this is assigned the address, uh, base address of the memory which has been allocated by the calloc function. So it returns a void pointer. So in order to point to a specific data type, so in order to point to double data type, so we need to typecast it. So that's why we have written here double star. So this statement allocates contiguous space in memory for 10 elements each with the size of the double. So that is what this statement means. Next is, let us see one example for this calloc function. So here, same, we have declared two integer variables n and I. So n is the number of elements here. So number of elements, so user has to give, suppose the user is given, so n value is equal to 5. Suppose number of elements to be stored in the suppose we want 5 integer values, so n value is equal to 5 here. So dynamically allocate memory for an integer array of size n and initialize it to 0. So with this function, with this statement calloc, what it does is, so it will allocate 5 blocks of memory, 1, 2, 3, 4, 5, and it will initialize all the values to 0. So the base address of this, suppose this is 1000, so that is stored in the variable ARR. So this 1000. So this will store integer values. If the memory is allocated successfully, then these statements will be executed. If the value in this address, if the memory is not allocated successfully, that means if this ARR contains the address 0. So 0 or null you can say. If the pointer is pointing to null, then memory allocation is failed. Memory allocation fails and the program is exited. So if memory is allocated successfully, then these are the elements. So these statements will be executed. So enter the integers. So enter the integer values. So by means of scanf function, we can enter the integer values at this particular address. So here, same program we have used for malloc and calloc also. So these are the statements which are used for printing all the elements, all the integer values which the user has given. Suppose the user is given, so this will be the output of the program. Enter the number of elements. If the user is giving 5, then if the memory is allocated successfully, then these statements will run. So enter the 5 integers. Then in the next line, suppose the user is giving 10, 20, 30, 40 and 50. So output of this is, so array elements. So these will be printed 10, 20, 30, 40 and 50. So this is the output of the program. So here it will be 10, 20, 30, 40 and 50. So in this way, my calloc function works. Next one is, the next concept in dynamic memory allocation is, or next function used for dynamic memory allocation is realloc, also called as reallocation function. This is used to dynamically change the memory allocation of a previously allocated memory. Suppose there has been memory allocated in the heap segment. Already some memory is allocated for, some memory of 20 bytes is allocated. Some memory of 20 bytes is allocated and there are some values here. So 10, 20. So there is some memory allocated 20 bytes. So if the user wants to, so these values are 10, 20 and 30, 40 and 50. So 20 bytes, 5 into 4. So 5 elements, size of each one is 4. 4 into 5 into 4 is equal to 20 bytes. Suppose these are 20 bytes and the starting address of this is 1000. So next element address will be 1004. Suppose the user wants to now resize this array. So if the user wants to resize this array, that means if he or she wants to store to 10. If he wants to resize this array to the size of 10 now, so in addition to this 10, 20, 30, 40, 50, so 5 more, so 20 more bytes will be allocated. So the user requires 20 more bytes. So already the user has 20 bytes. and this address is, suppose this address is 1000, 50, 60, 70, 80, 90 and 100. Suppose the user is having already 20 bytes of memory is allocated by using malloc, and if the user requires 20 bytes of more memory, so then that can be allocated by using realloc function. It is also possible that, so another situation comes where we need to decrease the size of this array. So suppose 10 bytes are only required. Suppose we need to store only two values. So 2 into 4, 8 bytes. So only 8 bytes are required. So that also can be done by using realloc function. So realloc function, what it does is, it changes the memory allocation which has been previously allocated. So either the new size can be more than the previously allocated size, or it can be less than the previously allocated size. If the new size is more than the previously allocated size, then old values will be copied to the old values also will be copied. But if the previously allocated size is less, if the new size is less, then old values may be deleted. So here, this is the syntax of realloc function. So realloc is the name of the function, and inside this brackets, so there are two arguments here. So first one is, this is the pointer which is pointing to the base address of the previously allocated memory. So previously already some memory is allocated. Suppose 20 bytes of memory is allocated. This is the new size. Suppose 20 more bytes are required. 20 more bytes are required. So then that is the new size of this that will be the new size of this statement. It takes a pointer to the old memory block. So what it does is, it takes a pointer. So here it requires two arguments. First one is pointer to the old memory block and the new size, and returns a pointer to the new memory block. So let us understand it with the help of one program here. So here in this program, so enter the initial number of elements. Suppose we are entering 3. So suppose we require only 3 elements. So n is equal to 3 now. So here n is equal to 3. This specifies the number of integers which we require. Now memory has to be allocated for this 3 integers. So memory required for this is 3 into 4, 3 4s are 12. So 12 bytes are required. So if the pointer returns null, then the program will exit. So otherwise, the memory is allocated for these 3 integers, and the user will give, and this is the scanf function. So this is used to read the integer values from the user at this particular address. So other way in which you can write it is, in this way also you can write with the help of pointer int ARR plus I. Then here, this is used to print the array elements, or to print all the elements which the user has given. The other way, in the printf statement, you can also write in this way with the help of pointer star of plus I. Then int new elements. Suppose, so this is another variable, new elements. Suppose enter the number of additional elements. Suppose the user wants to add 2 more integers to the existing array. There are already 3 integers, 1, 2 and 3. So 10, 20 and 30. If the user wants to add 2 more integers, so that is given by this new elements. New elements specifies the new size. If the user wants to add 2 more elements, so, and these two values are 40 and 50. So initially memory has been allocated to these 3 elements with the help of malloc function. So till here we have seen. So after that, memory has to be allocated for these 2 values also, for these 2 integers. So it can be added contiguously if space is available here after this 30. If space is not available, then these 20, wherever space is available, all these values will be, old values also will be copied, and this will be the modified size of this array. So here resize the array using realloc function. So in this way, this is the statement. So where we are using realloc function, realloc, then name of the pointer. So name of the pointer. So here pointer pointing to the previously allocated block of memory is int array, comma n plus new elements. So n plus new elements is, this specifies the new size. So already, so we have, previously we have given only 3 integers. Now it has to be 2 more integers has to be added to the existing array. So total size will be equal to 5. So this is the new size. So 5 into, so this will be the new size, 5 into size of integer. So 5 into size of integer means 4. 5 4s are 20. So 20 bytes of memory will be allocated. So if it returns null value, then memory allocation fails, reallocation fails. So if it does not return null value, then the values are copied at the particular specified location given by the pointer new ARR. So new ARR is the pointer which is returning the address of this, which is returning the address of the base address of the memory which has been allocated by this realloc function. So here it starts, for loop you can see here, it starts from I is equal to n. So where if n is equal to 2 here, so we have specified n as 2 here. So it will start from 2. Sorry, n is equal to starting 3 we have given. So it will start from 3. So already 10, 20, 30, these values have been entered. So next 2 values will be entered by the user. So at the end, using for loop, you can print all the elements of the array. So this is a simple program of making use of realloc function. This is a simple program of dynamic memory allocation by using realloc function. So what we have done here is, so we have allocated memory for 3 integers by using malloc function. First we have used malloc function, and the address which is returned by this malloc function is int ARR. So this is the pointer variable which we have declared. So this stores the address of the 3 integers. This will store the base address of the 3 integers which we have created by using malloc function. So after that, suppose we need to increase the size of we need to increase the number of elements. We need to increase the number of integers. Suppose 2 more integers have to be added to the existing values. Suppose 40 and 50 are to be added. Then these can be added by using realloc function. So these can be added by using realloc function. So memory has to be reallocated. So already memory has been allocated by using malloc function. Then by using realloc function, memory can be allocated for this 2 new elements. So total size will increase to. So in the realloc function, it takes 2 arguments. First is the pointer variable. So pointer which is pointing to the base address of the memory which has been allocated for by this malloc function, and then the new size. So total number of elements into the new size here is nothing but total 5 elements we require. So 5 into size of int. So 5 4s are 20. This is the new size which is declared. If it is, so in this way we can understand the use of realloc function. So this is all about dynamic memory allocation. Next, one more method is there, or one more function we have, free method. So free is also a function in C which is used to dynamically deallocate the memory. So in order to deallocate the memory which has been allocated by using malloc and calloc. So if memory is allocated, so this memory is allocated in the heap memory segment. So it is in order to free that particular memory. So in order to make use of that memory for other purpose, so we need to free the memory. So this free is a method in C which is used to dynamically deallocate the memory space which has been allocated by using malloc and calloc. So memory allocated using the functions malloc and calloc is not deallocated on their own. So we have to use this method, this function has to be used. So whenever dynamic memory allocation takes place, so syntax for this is free PTR. So PTR is PTR is nothing but the base address. It stores the base address of the memory which has been allocated by using calloc or malloc. So thus we have seen the different. So in this way, in this video lecture, we have discussed about the different functions. We have discussed about the concept of dynamic memory allocation and the different functions associated with dynamic memory allocation like calloc, malloc and realloc, and along with the free function. So in the next video lecture, we will discuss some more concepts of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.